Fault isolation mapping. Fault isolation mapping is a critical technique in problem management that involves identifying, isolating, and mapping faults within complex systems. This method helps in narrowing down the root cause of problems by systematically isolating potential sources of the failure. Fault isolation mapping is a structured approach used to identify and isolate faults within IT systems by mapping out all relevant components and their interdependencies. The process involves breaking down the system into smaller, manageable parts and systematically testing or analysing each part to pinpoint the fault. The importance of fault isolation mapping. Targeted troubleshooting. It allows teams to focus on specific areas of the system, reducing the time spent on problem resolution. Minimizing downtime. By quickly identifying the faulty component, downtime is minimized, leading to improved system availability. Improved documentation. It provides a detailed map of system components and their interactions, aiding in future troubleshooting and preventative measures. Key components of fault isolation mapping. Fault identification. Start by identifying the symptoms of the fault. Determine what part of the system is affected and what specific issues are being observed. System components mapping. Map out all of the relevant components of the system, including hardware, software, network elements, and their interactions. This map serves as the foundation for isolating the fault. Isolation techniques. Apply systematic techniques to isolate the fault, such as divide and conquer, swap testing, or the process of elimination. Impact assessment. Assess the impact of the fault on the overall system, including user experience, system performance, and business operations. Documentation. Document the fault isolation process, including the steps taken, the components tested, and the final diagnosis. This document is crucial for future reference and knowledge sharing. Steps to conduct fault isolation mapping. Step 1. Define the problem. Problem statement. Clearly define the problem, including the symptoms observed and the affected components. Initial assessment. Perform a quick assessment to understand the scope and potential impact of the fault. Step 2. Map the system components. Create a component map. Develop a detailed map of the system, including all hardware, software, and network components. Identify dependencies. Highlight the dependencies between components, as faults in one area may affect another. Step 3. Isolate faults. Systematic testing. Begin isolating the fault by systematically testing each component. Use techniques such as divide and conquer. Divide and conquer is where you break down the system into smaller sections and test each section independently. Swap testing. Replace or bypass components to see if the fault is resolved. Elimination. Remove components or functions one by one to identify the faulty element. And then monitor the results. Record the outcomes of each test to narrow down the potential sources of the fault. Step 4. Analyze faults and dependencies. Identify root causes. Once the faulty component is isolated, analyze its interactions and dependencies to understand the root cause. Assess system impact. Evaluate how the fault affects other components and the overall system performance. Step 5. Document findings and actions. Detailed documentation. Document the fault isolation process, including the tests performed, results obtained, and the final resolution. Share findings. Communicate the findings with the relevant stakeholders and update any system documentation or knowledge bases. Tools and techniques. Using network mapping tools to understand the network. Dependency mapping tools. Many ITSM tools are very good at identifying dependencies between components. There are also tools like Dynatrace and App Dynamics which can be used to map software dependencies and identify potential points of failure. Fault isolation techniques. As discussed, divide and conquer, breaking down the system into smaller sections for targeted testing. Swap testing, swap components to isolate the faulty elements, and the process of elimination, removing components sequentially to identify where the fault lies. Best practices. Thorough mapping. Ensure that all system components and their dependencies are thoroughly mapped out before beginning fault isolation. A systematic approach. Follow a systematic approach to avoid overlooking potential faults or interactions. Cross-disciplinary involvement. Involve team members from different areas to provide a more comprehensive analysis. Common challenges and how to avoid them. Incomplete mapping. Failing to map all relevant components and dependencies can lead to missed faults, ensuring comprehensive mapping before starting. Rushing the process. Avoid rushing through the isolation process. Take time to methodically test and analyze each component. Neglecting documentation. Proper documentation is crucial for future troubleshooting and knowledge sharing. Document every step of the process.